Thank you, Simon, for the introduction. So indeed, like I mentioned, I'm replacing Oliver for this talk about 3D printing and how it is currently in the market in relation to medical devices and certification. So as a project engineer for 3D Systems Healthcare, I will try to tell you a little bit about how we, as a contract manufacturer and a service provider, actually experience the process of bringing medical devices, 3D printed medical devices to the market, and where certifications and regulations come into the picture in this complete process. As you can see, as you will see, my PowerPoint presentation is mainly a sales presentation with a lot of slides. So due to the limited time available, I will skip through a lot of these slides and spend more time on a few important slides to really share that experience. So I'll skip this video actually, which is basically a testimony of one of our customers, how they experience collaboration from the medical device point of view. So very briefly, 3D Systems Healthcare, we are a organization of 3 different facilities, one in Denver, one in Leuven, one in Israel, Tel Aviv, with each their own expertise, which ranges from design, surgical planning of medical devices, through manufacturing, both patient specifics and volume manufacturing. And then we also have the expertise in Tel Aviv regarding virtual reality and surgical simulations. So, like I mentioned, these are the focus areas that we work on. And basically what we try to do with 3D Systems is to use 3D printing as an enabling and enhancing technology in each of these sectors. This is actually a very comprehensive slide to show you how we as a contract manufacturer work with medical device companies, with surgeons, in order to bring a 3D printed product to the market. So first off, what we will do is we will get on the phone, get on a WebEx with medical device companies, with surgeons, and we will discuss with them the design of a particular medical device that they intend to have 3D printed. This can be a patient-specific design, but this can also be an off-the-shelf product, a new product that they want to bring to the market. And what we will do is we will have our engineering group work together with the engineering team of the medical device company to really look into the design of the implant and how we can optimize that design for 3D printing. So while the medical device company or surgeon will take responsibility of functionality, so the performance of the implant, we will cover the aspect of how good is this design tailored to 3D printing. So we will try to get these people to step away from thinking about conventional CNC subtractive manufacturing and have them thinking about how can we optimize this for 3D printing to achieve the best results, to get a part that is functional coming off the machine while still maintaining the intended functionality. In doing so, we will also already look into not only the 3D printing point of view, but also any kind of post-processing that is necessary to really bring the product as it comes out of the 3D printing machine all the way to a product that is completely ready to be sterilized and implanted in the patient. So based on those initial discussions, we have several technologies available, going from stereolithography, selective laser sintering, direct metal printing, color jet printing, multi-jet printing, depending on the application, depending on what the part should be used for. A certain technology will be selected, and then manufacturing the part with that technology, we will then go into post-processing, which can be heat treatment, which can be some CNC machining for high accuracy features, and which also includes, for example, cleaning, to really bring the product to its final form ready for implementation. And in all these 3 aspects, we will actually think about how will regulatory and notified bodies react to this implant coming into the market. So manufacturing on our machines, the materials that we have, they are all conforming to the respective ASTM standards, working in validated process flows to ensure that the implants that are manufactured on our 3D printing machines will be accepted by notified bodies, by the FDA, as being compliant to medical devices. But also our post-processing, for example, our cleaning processes that we have developed are actually completely validated to make sure that any bacteria or any potential contaminations that might cause harm or infection to the patient, and also looking at validation studies, more than 40 validation studies performed, and 45 patents regarding validated procedures according to healthcare sectors that have been implemented in the market. From a regulatory perspective, mainly important on this slide is again mentioning that 3D printing is not this new to notified bodies and to regulatory agencies, is that you see that we as a company, 3D Systems, hold 510K approvals under the FDA by ourselves, which are mainly in surgical planning, workflows, procedures, software. Furthermore, through our manufacturing and our contract manufacturing, our services provided, we support one Class 3 device, which is currently in the market, which has gone through an FDA pre-market approval, which is kind of the toughest regulatory process you can go through for any medical device. And furthermore, we support the design and the manufacturing of more than 40 implants, which have been either 510K approved or have a CE marked as Class 2 devices. And in this message, I think what we experience as a global manufacturer, and which is a good thing about bringing 3D printing to the medical device sector, is that notified bodies and FDA do not see 3D printing as a whole new technology, or do not see 3D printed medical devices as something entirely new. They will rather look at the medical devices which are 3D printed as an equivalent implant compared to conventionally machined or conventionally manufactured devices, but just looking at 3D printing as a new enabling technology next to the existing technologies to just allow more design freedom and more opportunities within medical devices. Some of the products that we offer, one is surgical simulators. So I think most of you know how this works, where you have the surgical tools which are actually haptic devices, and then a virtual environment that simulates the surgery site that surgeons can just, or students can use the haptics device to train a particular surgery. And where we bring 3D printing in this story is that we will actually, depending on the kind of surgery we're aiming for, we will be able to print a 3D printed model of a patient-specific anatomy of the pathology that the surgeon is really looking into. And this is mainly interesting for not only training but also complex cases, because the surgeon will first be able to have a patient-specific model in his hands, but later on he will also be able to use these simulators based on the patient-specific, on the medical imaging data, to go in with the actual surgical tools and in a virtual environment, try the operation, try the surgery, get some feeling with how that patient's pathology will feel like before he will actually go into the OR and will perform the operation itself. Another thing that we have a lot of experience with is virtual surgical planning, and this is actually within this process is where we hold those 5 different 510K FDA approvals. So basically what we will do is look at the imaging data of the patient, go online with the surgeon and basically plan the whole surgery from step to step. Where will we make cuts in the patient's bone? How will this bone be repositioned? What does the end result have to look like? Where will we need patient-specific implants? Where will we be able to use stock implants? So the whole surgery from front to finish will be planned. And based on that planning, guides will be designed, cutting guides to know where to cut the bone, where to drill holes, positioning guides, how to reposition the bone, and if necessary, also a patient-specific design based on this imaging data will be designed in this phase. Once the guides have been designed, the implant has been designed, we will go through an approval process together with the surgeon to make sure that everything is exactly according to the expectations. And after that, we will go to 3D printing of the guides, 3D printing of the implants, if that's the case. And then the surgeon really has a complete package to go into the surgery and make sure that the surgery is performed exactly according to that virtual plan. And as this complete procedure with all the guides that are designed along every step along the way is a 510K approved procedure, this complete virtual surgical planning is actually valid to use as a surgical tool in itself. And these models can be taken into the OR to perform the operation. Two examples of these, which are pretty interesting, is orthognatics cases, where we will do repositioning of the top and the lower jaw of the patient. And as a result of that procedure, we will get splints that will show the post-operative position between the top and the lower jaw. And actually, this material of the splint is USP class 6 approved, which means that it is allowed to stay in contact with the patient's mouth for 6 weeks, allowing the bone to heal in the correct position as it was planned during the surgery. And then afterwards, the splint is able to remove, and the patient will be able to start rehabilitation. Another approach that we can take with virtual surgical planning is reconstruction. So this is an example of where the fibula, so the bone in the calf of the patient, is used to actually reconstruct the lower jaw. And again, here, based on the virtual surgical planning and the anatomical models that we can manufacture and provide to the surgeon, we will decide where will we make the cuts in the fibula, in the lower bone, to really be able to reconstruct the mandible of the patient in as good a way as possible. And these guides will be printed to, in the OR, immediately fit on the patient fibula, cut the bone in the exact pieces that it needs to be, that they can immediately transfer these pieces to the patient's maxilla and have the reconstruction match the virtual plan. An entirely different sector is direct metal printing. In direct metal printing, rather than focusing on patient-specific approaches and virtual planning together with then the guide design and implant design, for metal printing, we actually are a service provider and a hardware provider for metal 3D printing machines that allow off-the-shelf manufacturing of metal implants, titanium and chrome. And here we work mainly with medical device companies, which are the legal manufacturer owner of the design, where we provide them the support to make sure that their design is feasible for, or is suitable for 3D printing, and that is also optimized to really go to a cost-effective, reliable volume production supply chain. In healthcare, I can say that the ProX DMP 320 is really the flagship machine. I think within our company, we have about 40 machines installed running full-time medical devices. Volume production mainly. 3 more will be added by the end of the year to expand our capacity and better meet the needs of our customers. While the other machines, the 300 is mainly for industrial applications, where 200 and 100 are mainly smaller size machines which are used for dental applications. So on this ProX DMP 320, this is just a grasp of the materials that we have available. So 3 different titanium alloys as well as stainless steel. We have cold chrome and 17.4 precipitation hardened steel coming soon. And the takeaway message from this slide, I guess, is actually that these materials, the machines, the parameters, the use of powders have all been optimized to result in a 3D printed component which, both from a mechanical composition point of view and from mechanical properties, meets the ASTM standards. And this will help a lot in bringing a 3D printed medical device to the market. This is mainly some key features that I want to tell you. The machine is optimized for volume manufacturing, for reliable supply chain, including some hardware and some software solutions to maintain traceability, such as the possibility to introduce unique device identifiers directly onto the implant in an automated way, but also flexibility. If you want to switch different materials on the same machine, or if you want to achieve a high turnover, one of the features that we have on our machines is a removable print module. And compared to a lot of other 3D metal 3D printing machines, this will allow you to actually switch materials within the same machine or start the next manufacturing run within less than an hour of the first manufacturing run ending. And although this is not that interesting for patient-specific implants, medical device companies who are looking at volume manufacturing of thousands and thousands of implants a year, they can really benefit from every hour that you can save in having your machine now. Some very quick applications that I will go through examples are anatomical models. So these are manufactured through as a layer of color jet printing. I think some of the other presentations before have already alluded to what these can be used for. So just for the surgeon pre-operative planning to see what the patient's anatomy looks like. We also have some plastic surgical applications such as knee cutting guides, which are patient specific, to the anatomy to have a higher accuracy of actually then implanting a stock implant. The cutting guides I discussed before, and a scoliosis brace for after spinal surgery to provide better support of the patient's spine during regeneration. Some metal examples, we have porous hip cups in titanium, where you can see that the inside is actually CNC machined to provide optimal accuracy for having a ceramic or polymeric insert that will then interface with the femoral stem. But on the outside, we have porous titanium, which will allow better bone attachment, better bone ingrowth compared to a solid implant. We also have a custom tri-flange spinal fusion cage, where you can see the same core structure present, allowing that bone ingrowth. Dental applications, we have some abutments. These bridges are actually a very nice application of not only 3D printing, but the complete process flow, where we have a coupled chrome alloy, which is specifically to the dental market to meet the thermal expansion coefficient of the ceramics that get baked on top of this implant to prevent the final dental implant from cracking, and this is 3D printed. But these implant connections, which have to be very high accuracy to ensure a good implantation to the patient's skull and thereby a good bait, these will then be CNC machined afterwards to provide that necessary accuracy. And then some other applications that we work on is here a cardiovascular pump cover for a heart pump, some hooks for craniomaxillofacial surgery, and a veterinary implant which is used as a wedge for bone building in the dogs, actually. So I think that was mainly my presentation. Hopefully it gave you a small idea in this limited time of how we as a contract manufacturer experience bringing medical devices to the market, and also shows you that actually medical devices which are 3D printed are not entirely new, but that it's just something that's gaining popularity day by day, and I guess you'll hear more about it in future as well.